Thank you very much for giving us this opportunity to talk about light and energy saving potential in buildings. I'll try to make it as wide as possible because energy saving is the last point I'll present. I'll present the first parts that we think is important whenever you do a lighting solution for any building. So let's just start out. Light influences us in many, many ways. And in our daily life, and daily line of work, we normally talk about three parameters. It's the visual, it's the biological, and it's the emotional. And I would like to go through each one of them for you so that you get a grip about what we are actually considering when we do lighting in any buildings. The visual is everything about legislation, all the norms, the standards that we have, the ISO, the European norms, everything is based on visual performance. The emotional is normally what we experience in theaters, in shopping malls, in places where we want to evoke an emotion in people's reactions. And the biological is a pretty new area where we actually measure how our hormone levels, our body core temperature, our biological feedback on lighting is measured. Now the visual one is, we say normally 150 years old. It's very, very well documented. We have very solid evidence in that, and it's all scientifically based, evidence-based research and the stuff that we work with as engineers and researchers on a normal day. The emotional is individual. Everybody can say, I like this light, I hate it, I love it, I feel energized, I feel bored, and it's very hard to quantify. We are doing a lot of research projects around the world in universities to try to find out what kind of lighting design influences different moods in people, but it's always subjective, and we always have to ask people to put them in some lab conditions and then interview them, so it's a bit more fluffy. The biological is a relatively new thing. I'll go through that a little bit later, but in 2002, an American research team found out that we have an extra receptor in our retina, and that receptor controls biological functions in our bodies, so that by illuminating that receptor with specific wavelengths, intensities, and color temperatures, you can actually influence your biological system like any other system, like you just showed us, where you influence biomechanical interferences. So if we start off with the visual, it's, as I said, primarily about solving visual tasks. Having enough light to read your papers in front of you, having enough light to do your notes, and having enough illumination to do any visual task. And this is very well regulated all around the world. We get a project like this hotel, we flip open a standard, and we do the dimensioning of the lighting according to that standard, and then you sort of have solved the issue for that university, school, library, hospital, whatever. Everything is very well standardized. Our challenge right now is to tell people that standards are minimum requirements, because you can do so much more. You can do massive amount of energy saving, you can do emotional implications, you can influence people's health by adding to the standards, and that's what I would love to share with you guys today. The light creates the space we're in. It gives us a feeling of the shapes of this space. So if we use this room here for an example, when we look around it, we get an impression whether the room is big or small, high to the ceiling. All these kind of dimensions are being put to us, and the shapes in here, how the chairs looks, how the how the escape route looks, and so on. And we get a feeling for the shapes, as I said, inside the space, and the relationships of the sizes. Is the windows small compared to the ceiling size? So these kind of dimensions, we do that all automatically. We don't think about it, but it influences our way of perceiving a space. And we want to do that. We want to do all that without creating glare and discomfort, because we are trying to put in global standards that are regulating discomfort glare, but discomfort glare is psychological. So when I look at these bright light sources in the ceiling, I might have a certain feel that they are a bit too bright, and when I look at these ones, the small ones here, they are more pleasant to look at. But how do I rate that? And how do we do that in a standardized measure? Because we want to avoid glary light sources. Just to add a little bit more conflict in that is that the glare calculations algorithms for daylight are not compatible with glare algorithms for electric light. So we cannot say that the overall glare emotion in this room here is these two added together, because it's different assumptions and different algorithms. So the purpose of doing these standards that we started off in the late 1800s were about creating safety. It's about being able to see there's a staircase here, so I actually put my foot on that and I don't fall over it. So basic function of lighting is creating safety for people. That we don't want to fall over anything, we don't want to bump into things and fall off a building. And that safety is supposed to create security. And this thing about security, I can share a story with you guys. When I was flying from St. Petersburg to Ekaterinburg in Russia, I flew with a regional Aeroflot airplane. And when we got into that airplane, I normally do that sweep like you do everywhere where you are to feel secure. You see how many people are in here. Can I get out of the escape hatch? How does the escape route look like? And in this old Aeroflot airplane, there was like a hole this big with a handle like from a submarine that you would open and then jump out if something happened. And a quick look around in that airplane was about half of the people in there wouldn't have a chance to get through that hole. So I was just sitting there refueling, or the plane was being refueled at the airport in St. Petersburg, and I knew if that would catch fire, I would die, because I wouldn't have a chance to get out anywhere. And even though, when we are refueling, you're not allowed to buckle your belt, well, that would help a lot in that case. The issue is that we do that all the time, and that's why the stewardesses are very kind at telling us about the lid strip in the floor, the escape over the wings, in the front, in the rear, big hatches so we can relax and enjoy. And you do that in this hotel. Every move you do, you just sweep the area. Is it easy to get out? Will this guy kill me? Or whatever, all the risks are coming up. We are doing that analysis all the time based on our visual impressions. And that's why when we do good lighting, we create the feeling of safety and security in the hotel, in the shopping mall, in the school, in the airplane as well. Because we are aiming for well-being. You've probably heard about the well-being standard that's sort of booming all over and rushing and crushing all our other standards because people want well-being. The first thing you have to be well-being is that you can calm down, relax. The only way you can interact with me, looking at me and staying here is that you feel safe. If you were afraid that the ceiling was crashing because from structural damaging, well, you wouldn't be sitting here, you would be leaving. So it's that, and we do that all by visual inspection all the time. So many of our customers request well-being, and we hope with some research projects that we are funding right now that in maybe 5 years we can do lighting that actually sustains the feeling of flow. Because if you're talking to people working in an office environment, library, university, they love that feeling where they suddenly could, wow, an hour just disappeared, I did my entire report, it's wonderful, I want that feeling again. I want that feeling of flow in my work process. With a little luck, in 5 to 10 years, I can come back if you want me to and tell you guys about what we've done to create and sustain flow in office lighting. And that's all the visual stuff. Everybody in the lighting industry does that. We are doing huge research projects together with Ucini, together with Suntobel, together with Tridonic, because we all want to achieve that. So it's nothing that we are competing against, it's just common sense that we want to create these things here. But I want to go a little bit back because you guys maybe have a little perspective on this. So everything started, our evolution started under the spectral radiation of sunlight. Before even humans were created and animals were created, we had the spectral distribution of the sun when the earth was created out of dust revolving around the sun. So if we wind up to 7 million years ago, where our ancestors diverted from the monkeys and started to evolve in the Homo sapiens direction, that happened under that light source. That was the only light source we had. We had the direct sunlight, the diffuse light from the cloud. It's a two-component system where we have a direct light that creates shadows and textures, feelings, and we have the diffuse that soften up the very bright light from the sunlight. So that light source was readily available for us, and in the night we had this light source. Light hitting the surface of the moon, bouncing back to Earth, and lighting up the environment. On a bright sunny day, we have 100,000 lux, the unit for light levels. On a bright moonlit full moon night, we have 5. And if we have a half moon, we have around 2.5 lux, and the starlight gives us approximately 0.1 lux. But in this area, we can do a jogging, we can run in the forest, we can read a paper if we are relatively young. There's actually enough light to work. And it's not that strange, because over a period of 7 million years, our retinas and our sensory system was calibrated to that light, because that was the only light available. So we had sunlight, we had starlight, and we had moonlight. And in starlight, our central system in the eye shuts down. We only have peripheral vision, so we can sort of feel if something is going on around us, but we can't read a paper, and we can't do a jogging in the forest. In starlight, it's simply too low lighting levels. And our history as man, evolution, started here in this area here called Sub-Saharan area. And in this area here, we spent the first roughly 7 million years of our evolution. So when we talk about human-centric lighting, we want to do lighting for people, we check out how was the light in Central Africa. How does it behave? How fast does the sun rise? How fast does the shadows change? What's the color temperatures? What's the intensities? And all that is how we have calibrated. Then 1 million years ago, a bright guy came home with a stick on fire and said, look what I found. And we had the first, what we call artificial light. It was actually just men picking up a stick that happened to burn somewhere, and we started to work with fire. That's the first time we had light in the night. That's the first time we created a feeling of security for wild animals, enemies, whatever that we were scared of, because now we had the availability of light. The campfire is very different from other natural light sources because it comes from below. It's warm, it's moving at a different pace. So when we are being lit up by candlelight, kerosene, incandescent lamps, campfire, we relax. We open ourselves to discussion, to talk about emotions, to interact with our friends, because we are in an environment where we can't hunt, we can't gather. We're sitting here, we're just having a great time together, talking about how we will evolve humanity, and we had about 1 million years to do that, and that went very well. Somewhere between 50,000 and 100,000 years ago, we decided to leave Africa. And nothing has changed since we did that. Our brains look exactly the same, our eye structure looks exactly the same, our perception system, everything looks like it was when we left Africa. So we are now sitting somewhere here, somewhere here we are. And that's pretty good, because we're pretty close to equator. We were born on equator virtually. Very fast sunrises, very fast sunset, dark nights, bright days. But when we, like the other idiots, moved all the way up to Scandinavia, where I come from Denmark and Sweden, pitch black all winter, very bright all summer, and we just can't cope with it because we are calibrated to 12 hours of daylight, 12 hours of darkness. And that's what we expect. And whenever that sort of doesn't work, we're like, I don't feel good. So this is the system, and as long as when we talk about doing lighting for people, just think about it. I do a one-day workshop where we try to discuss about how lighting would be if we lived here today. How would it look like? How would it look come into the windows? How would we feel by being there? And when you work in the Middle East, in Egypt, in Dubai, whenever you are actually in very ideal conditions for lighting, and as soon as you move to South Africa or to the northern parts of Sweden and Denmark up here, it's very, very different. And that's why we have triple suicide rates in Scandinavia, massive alcohol abuse in Greenland, alcohol abuse in the northern parts of Russia, in Ukraine, in Alaska, all the way up there, people just can't live there. Nobody lives down here, you know. It's just empty because it's the same, it doesn't work. So if we wanted to have all the good stuff, we would stay in the Mediterranean area, we would stay in Central Africa, India, like on this path that's equator plus minus 10, 15 degrees. That's the place where we go for vacation because it feels good to be there. And this system here was calibrated, it was developed, it was calibrated, adjusted for that kind of light. You know, we have the cornea, we have the opening in the iris, we have the lens, and we have our sharp center vision here at the back of our eye, our fovea centralis, which is a 2-degree high 4K HD resolution sensor in full color. So when we are in there, we have all the bells and whistles, but we only have it in 2 degrees. So if you stretch out your arm, look at the size of your nail of your thumb, that's approximately 2-degree sharp center vision. That's why when I'm looking at you, I'm just using my sharp center vision and I can't see the rest of the guys. That's why we need to look at each one in turn, because we only have this small sampling area. So when you come to a friend's new home and you go in there and see, look how my decorator fixed my home, you start mapping with your 2-degree vision, you store it in your perception, and then you have a 3D computer model of your friend's home. So next time you get there and they've put some new flowers, bought a new chair, put some artwork on the wall, you say, oh, because you compare what you just sampled with the memory of your 3D computer drawing that you have in your mind. And this system is calibrated for daylight. So when we lived in Africa and we wanted to survive, it was a smart idea to see a lion far away. So we were very, very good at looking very far away. To look far away, we need a flat lens. These muscles here, they tense the lens, it flaps together, and we have a sharp image on our retina down here. So if we see a lion coming 2 kilometers out, we can climb up into a tree or we can run away or whatever. It's not smart first to detect it 60 centimeters away from us, because these they just extinct for some reason. So what we are good at is looking far away, but we don't do that anymore. We look at the computer screen 80 centimeters away, and we look at these all the time 40 centimeters away. And when we look at things nearby, these muscles relax, they don't have to work, the lens curves and the eyes is wonderful. So if we're a little sloppy, we work on our computers, we look at our phones, our eyes just tells us, it's great, I don't have to do any work. And most of us will notice that it takes a while to look away from the computer and look at you in the back, and my eyes have to stretch the lens. For me it takes 2 seconds to do that focusing. But if you're younger, it takes a little bit, it goes a little bit faster. But we don't know how it will go with the kids who are more like living in this world, you know. So it's a very different scenery than what this gear is evolved to do. So remember, the device that's scanning the area is done for outdoor scanning in Central Africa, and we do indoor scanning in Athens, which is a different task all in all. So it's all good that we can do all these things, and as I said, everybody in the lighting industry does these things. We just have to think about some of the other things, because we're used to having a very, very bright light source, the sun. It's pretty high up, and it has this beautiful sky that is brightly illuminated, so the difference between the light spot and the background is not that big. But in here, we have like a bright light spot and a relatively dark background. Now let's take these ones. These are the bright light spots. Luckily, some brilliant guy has put ambient lighting on this area over here, because when you guys over there are looking over here, this doesn't feel as uncomfortable as they would if there was no light on the back. And that's what lighting design is all about, creating that space where you feel good inside. You still have to fulfill the standards, but you can probably do that with half the amount of energy. The rest is just adding in for us to feel good. Now when I did my thesis, it was on calculating on trying to measure discomfort glare, because right now we can only calculate it, we can't measure it. It's been like that for 32 years, and we still can't measure it. It's very frustrating. So, but anyway, it's a bright object and a dark background. Like when you drive your car at night, somebody comes against you with the headlamps on, and you have that feeling, oof, this is uncomfortable. That's actually what we define as discomfort glare. We have a rule of thumb. I'll show you that later. But when we have guests, or when we had guests for a period at our factory in Sweden where I work, we had built this little room here to do some testing and to make people understand what discomfort glare is all about. So we had a guest coming in, we gave him or her a remote control in the hand, and they could adjust this lamp here to a certain discomfort level that they found. Now it's too bright. They were standing there adjusting it a little bit, and then we measured the luminaire luminance, how bright is the surface of the luminaire, and we compared it to the background luminance, because it's the ratio between these two that actually defines discomfort glare. And then when the test person said, I think it's too bright now, then we asked them to use the other button on the remote and start to illuminate the wall, and they would see, okay, now it's pleasant again. And it's a very hand-on experience that it has nothing to do with the product, because the product is exactly the same. It has the same luminance level. The only thing is that you change the background and suddenly it feels pleasant. And in a normal setting, you can do that 3 times and you will end up with a graph like this. Because when we do lighting design, when we develop a product like the one in the ceiling, we would measure the brightness in candles per square meter, the luminance of the fixture. Let's say these ones are probably 3,000, and then you can go out here, blah, 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 blah. Okay, I need a roughly 50 candles on the background to make it feel pleasant. So this is comfortable, and this is common knowledge that this line is, if you're down here, it feels comfortable to be with the fixture. If you're up here, you're in the discomfort zone. Now, having had a few hundred guests through this little setup, we actually came out that this was what we hoped to prove, but this was what we actually got. We got a curve that was surprisingly lower. Okay, the vast majority of these people testing here were Scandinavians who probably have a different cultural background than if, for instance, it would be people from Dubai who did the testing. But what we have found out is that we have to reduce the brightness level of the light source or the appearance of the fixture, maybe down to, let's say, 1500, and then we have to increase the background luminance. And we put that 15 years ago to our R&D department. So when people sometimes tell me, your fixtures are boring, nothing is happening. Yeah, they're boring, but they're nice to be with. That's sometimes like friends. Some of them are boring, some of them are nice to be with. So it's a little bit like, if you know, we follow that rule here. So if we do a fixture, we wouldn't do a fixture like that. We would probably have acid matted the glass or sandblasted the surface, so the surface is a little bit bigger, a little bit softer, so we come down in surface brightness and then add wall washes as they've done here as well. So this is when you work with R&D on light sources, that you always have to remember that the receiver is the human eye, and in the larger scale, the human perception system. Are you with me, or am I just babbling on? You're with me. Thank you very much. The last thing I want to go into is the biological thing, because this is really new. In 2002, a gentleman in the United States, Jörg Scherrer, he found that we have an extra receptor in our retina, and that was pretty surprising, because we have thought, I've been teaching for 30 years, and to begin with, we thought that we had photosensitive skin, because we know if light illuminates our skin, we wake up. And then we thought, no photoreceptors in our skin, can't be that. Then for a period we thought that the blood itself was photoreceptive, because we have a very thin layer of skin that's covering our arteries and our veins, so we could argue that light penetrates the skin, hits the blood, and carries the information to the entire system that we are awake. You could actually rent lamps that you could strap behind your knee when you had transatlantic flights. Maybe some of you remember it. You could buy that, you would rent them at Lufthansa, and you strap that little lamp on that was illuminating, because the blood flow between these two muscles and a very thin layer of skin here could reduce jet lag, and it worked. It's all about placebo. So the idea is that actually none of that works. It's the eyes. We have the receptor in our retina, or at least that's what we believe now. So when we talk about biological systems, it's very concrete. It's when people have tired eyes, it creates headache, migraine, epilepsy, and that you can test in a very closed setup in labs and we do that around the world. But the primary system is our sleep-wake regulation. And that's what this sensor does. It tells us when to go to sleep and when to get up based on the amount of daylight that hits the retina through our eyelids all the way into the system, and it's extremely sensitive. When we are up in the Scandinavian countries, as I shared with you, we have the SAD, the Seasonal Affective Disorder Syndrome, where we actually are disturbing this rhythm. So we have a concrete problem with people not sleeping in the summer, trying to sleep all winter in hibernation, and we have a massive amount of depression that's caused to disturb daily rhythm. Jet lag is an example that most of us can experience if we've been flying cross-Atlantic. We know that we are out of adjustment, and you can actually only force it back in a 2-hour slot every day. So it takes 2 to 3 days, then you're back to the light setting where you are now. My biggest concern right now is what we're addressing is social jet lag. It's our kids, primarily the boys from say 15, 16 to 21, who choose to play computer games at night with their friends and sleep long in the morning. So they are on a social behavior linked with friends, actually making jet lagging themselves every weekend. So it takes Monday, Tuesday to get back in the school work rhythm. And it's a huge problem because we allow them to do that, and they do it voluntarily. Actually, it seems that a lot of kids are telling their mothers and fathers they go to sleep at 10 o'clock, they kiss and hug, and then they set the alarm for 1 o'clock and play from 1 to 4 in the evening, and then they are very tired next morning when they go to school. So that's what we help schools addressing these things, that telling people, I give this lecture to teachers, to a massive amount of people, to make them understand it's so important that you follow the daily rhythm, not to get depressed or end up with migraine or epilepsy and stuff like that. So remember that what we have found out with this biological system is it's all about creating a good night's sleep. And on a money base, we think that this is probably things that people will buy. So if you somehow can sell them a product that saves 80% on energy with pumps, as you just shared with us, if you can sell them a system that makes them sleep good at night, they will probably love it. We see what people are spending on expensive beds, relaxations, meditation facilities, all together, because that's the one thing we can't buy, it's a good night's sleep. But maybe we can do it if we live a little more consciously. We call this the Circadian lighting solutions. And the Circadian lighting became a term when Burson and Brainard in 2002 discovered what we call intrinsically photosensitive retinal ganglion cells. And they are sensitive. They are actually a blue light sky detector that sits in the bottom of your retina. So when you go out now, take a walk, the entire globe of the sky is being illuminated at the bottom of your retina. And this spectral distribution, blue light, sunlight, very high intensity, when that hits the bottom of your eye, it tells your system it's daytime. And it's been so like our ancient ancestors started to walk the earth around 7 million years ago, and we can't do anything about it. When the night comes, we have the warm colors, the red light, the low intensities, and when that happens, the body says, okay, it's time to go to sleep. And it's the same in every mammal around the world that is active during daytime. And when that happens, we stop producing our wake-up hormones, or we start to produce our sleep hormone, and we become tired. Now this is, because you probably heard most of this before, but the issue here is that it takes 45 minutes of exposure to bright light, then you're awake for the next 6 hours. So if any of you guys commuted to this place this morning, you walked outside, you were out smoking, you had a coffee outside, you were exposed to bright levels of daylight, you'll be awake for the next 6 hours. But the vast amount, only 4% in Europe gets enough daylight. So it's really, really serious. So the vast amount of people going to work are commuting to work, they come in happy, smiling at the office and say, hi guys, good to see you all, you are happy, you're easy to work with. And if you have a good coach, he'll say to you, do all your creative work from 9 till 11, Then you have a few meetings, and in the afternoon you can sort out mails because you're a little bit more grumpy in the afternoon. Yeah, that's right, because you're more and more tired, because that goes very nice to the hormone levels in your bloodstream. So when we're in here, there's no blue sky over our head, and there's not enough light, so your body tells you right now, go to sleep, go to sleep, go to sleep. And that's why we don't want meeting at 2 o'clock in the afternoon, because that's 6 hours after we came in. We're yawning, we're boring, we can't keep students awake at a presentation because our entire hormone system screams, go to sleep. So we need to get out in the morning, we need to get out just after lunch, get these 2 bursts of light, then you can manage an entire day. The worst thing is actually we can control this. That's not the worst thing, but the good thing is we can do that during the daytime, but we can't make people sleep in darkness. Somehow, over the last 15 years, it's become a bad habit to have a little light on somewhere. But we are made to sleep in absolute darkness. And as soon as you sleep with a little lamp on, or in Scandinavia in the summertime with the sun coming through your windows, you don't have a good night's sleep. But everything is rooted in this system, and it's here in the bottom, in this layer here, we have a distribution of these intrinsically photosensitive ganglion cells that are calibrated to this color, 480 nanometers, with a very high intensity. So when that hits, it's not enough to do a laser or a narrow beam, it has to hit the entire area to trigger the effect. So you cannot just, we know that we need this huge angle vertically from horizontal and up. That area has to be lit to illuminate the bottom of your retina. And you do that by being outdoor. So circadian lighting is a lighting strategy or source that is efficient in stimulating the circadian system. And today, we know about it. They got the Nobel Prize for developing the model in 2017. So it's very, very well known. It's not voodoo or black magic or anything. It's just well-established science. It's just not very well spread yet because it's a relatively new discovery. So one of the ways that we could use this is by implementing it, let's say, in an office where we go out with 500 lux, as the legislation says, a warm morning light. Curve over here shows us where we are during the day, so this could be a typical morning setting. And when everybody comes in, we want to boost the light level, so we go up to 1000 lux, which is a lot of light. We have cool color temperatures that matches the color temperature of the sky, and we have that for an hour in the morning so people can get a boost and stay awake. Then around lunchtime, in order to save energy, we go down this slope here. We keep the color temperature at 6.5, which is the daytime color of the sky, but we go down to 500 lux here to save energy. And then when we come back from lunch at 1 o'clock, maybe 1:30, we need to have a certain boost. So here we boost again up to 1000 lux with this very cool color temperature. And during the afternoon, when we prepare to go home, we start winding down the lighting level to 500 and the color temperature back to the sunset color modes. And if you do that, your body will follow the daily rhythm outside. Actually, the Central African daily rhythm, because that's the one that works. Now, a lot of people ask me, why do you do this dip here? Well, it's because we would love to have a curve that looks like that, but that would be a massive amount of energy. So we just dip here and use all this energy in this ditch here to do energy savings. And by doing that in an intelligent way, we can almost stay within the European demands for energy use for lighting. Because if you want this effect, you need to throw in a lot of energy. And that's the downside on this. So a buzzword that's coming around for the time being is human-centric lighting. Human-centric lighting is a very wide framework where a lot of things goes in, and circadian lighting is one of them. Very often people mix them or replace them with each other and think that circadian lighting is the overall, but human-centric lighting is all about doing lighting for people. And circadian lighting is doing lighting for the hormone system, the evidence-based system where you actually can tap in a needle, and turn up the light, and you can measure the level of rising cortisol in your bloodstream and suppressing of melatonin. And as soon as the light goes away, the balance changes slowly, and you become tired and go to sleep. Okay? Crystal clear, that's great. Now this is where I've been living most of my life. It's creating emotional effects because I've been in the business now for 32 years, and this, what is now hot with the circadian system, wasn't existing at that time, so it was all about emotions. People wanted to feel good, and now we can back up some of the feelings with medical data, which is really nice for us. Now there is a lot of philosophy in this, and this is a beautiful picture of a forest, and you can say, is the forest out there right now? And you know all these kind of philosophies where you say, maybe it is, maybe it isn't, we can't know because we don't watch it. Things are only there when we see them. Maybe there's no forest before we go there. Then we can say, now the forest is here, maybe it's gone when we're walking home. So everything we experience in the world is somehow what we think and what we see, what we feel out there, and that picture is coming in through our eyes, and it creates an emotion. If we are out here, we feel good, we feel like we are being outside in nature, or we feel we are with a friend or whatever, but it's based on it's vastly based on some kind of picture that's going into your eyes. From your eyes, it goes from the visual cortex all the way to the back of your brain, where about 1/3 of your brain power right now is allocated to visual processing. So you put a lot of emphasis in this, put a lot of power, a lot of energy to try to understand what's going on outside in the world and what are you seeing. So I wrote a book about it many years ago. It was 2009 when we published this, and it was called Light and Communication because we needed a reference and that we were lacking in lighting design, where we actually tried to understand that this church here in this little picture is like emulating the wave, the sky shape, or the shape of the clouds, and it's the same color as the sky, and people feel connected to the divine or whatever in that church, and they want that kind of light. So normally, if I can, I take clients and customers out and say, let's find somewhere in nature that you find great, you want to have, and then we try to replicate that. Sorry, I'm in your way. We try to replicate that by doing the lighting design. But the big thing that what I think is a big thing I can share with you guys now is that I try to introduce the idea that light is a carrier of visual information. Because if we were in here and everything was pitch black, I don't remember, if you remember an old lecture hall, there were like 4 spots on a line up there, and there was some guy standing here with all the spots straight in his face, and I couldn't see if you were here, if you were asleep, if you were listening or anything. But now we understand that we need light on the presenter, we need light on you guys listening, so I can interact with you, see if you're with me, and we are having this visual communication all the time, because that makes all the difference. Otherwise I could have called you, or we could have a speaker up here having my voice, but it would be a different experience because we don't see each other. So this idea here is, it's not my idea, I must admit. I just snatched it, and I snatched it from the Bell Laboratories and AT&T research in the United States. And I had a presentation at the conference in Berlin in 2009 where the book just was published, and I needed to share that story with them, and I would like to share it with you also because I think it's a great story. It's a story about a student who lived in Iowa in the United States, and he moved to a university in New York, and his mother was very sad that he would leave her, and she was alone on the farm, and it was difficult. We are back in the 1920s. So he promised to write every week how he was doing in New York. And he wrote a letter home, and she replied, and that kind of communication was pretty well known at that time. You could talk to people or you could write a letter. Then when he moved in a flat in New York, in the hallway, he suddenly found this device hanging, and he asked the friend, what's that for a device? And he said, it's a device where you can talk with people who are far away. Oh my God, he said, can I talk to my mother? Sure, and then he picked it up, hello mother. That wasn't exactly the way it worked, right? So he handed it back, and the guy said, whoa, 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 you have to write a letter to your mother because she has to have a device like it so that you actually can talk to each other. Okay, he wrote a letter, said, Mom, go buy a telephone, and his mother went there, bought a telephone, and now they both had it, and that was okay. But there's one thing lacking here, it's the connection between these two devices that needs to be there, And that's what the researchers at AT&T and Bell Laboratories worked with, coming up with a theory back in the 20s and 30s how that worked. Because when the wire is in place, it works very well. The student goes out into the hallway, puts in a few cents here, dials mommy's number, and then she answers in the phone, and it's like magic. Wow, she's next to me, I can speak to her. It was a groundbreaking thing, and they loved it. So the student, he started to call his mother frequently, and it was so convenient. So the mother said, can you call me like Monday or Wednesday? Okay. And then it was Monday, Tuesday, Thursday or Wednesday? And he was like, shit, it's not that funny to report everything to mother, and I'm actually getting out of sense here because I'm feeding this machine all the time. So he came up with that idea. That's why the story is called the Poor Students Channel. And he said, Mom, maybe you can call me, and we can agree on a point. You can call me every Monday and every Wednesday at 8 o'clock, and I'll be standing in the hallway. So Mom calls, he takes the phone, it's free for him. Mommy has the bill here, and it works in a different way. But after a while, he got a little bit tired about being interrogated. How are the studies going? Have you got a new girlfriend? Are you eating enough? Are you clean clothes? I said, come on, once you hear that every weekend, it doesn't work. So he came up with this idea that they made a code. So he said, well, if I don't call you at Monday, I'm fine. So you just calm down. If I call you Monday, it's to tell you there's something wrong. So you can be calm every Monday. So he's actually transferring information that he's okay and he's calm every Monday by doing nothing because the system is in place. So he refined that to, if I'm not calling you on Tuesday, I have enough money. If I don't call you Wednesday, I have the same girlfriend. If I don't call you Thursday, my clothes is clean. So his mother got a lot of information, and AT&T thought about, how are we going to charge people for that system? Because they can use it that way, so we won't be able to fund building up the wiring. And the moment the wiring is gone, this system doesn't work, even though they're doing absolutely nothing, but it depends on a well-functioning system being in place, otherwise it wouldn't work. So that's what the research is. We put the wire back on and then the system works. And if you break that down to seconds or split seconds, it's massive amount of data you can transfer without doing nothing, without adding any cost at all or using any money. So that's why they had this mixture for many years. It cost something to establish the contact, it cost something to talk. Now this system is probably disrupted like any other systems, but it was a very, very good idea. And that's how we started thinking about how is it with people. Why do we meet? Why do you come here to Athens? Why do we fly down here from Sweden to meet you guys? And there's only one reason, it's because we want to see each other. And this is very powerful when I'm in Australia or in New Zealand, because then I travel like 2 days to get there. People drive 600 kilometers to get there. And that's clearly important for all of us because we do that all the time. We travel the world, we fly too much, we do all kinds of stuff, but it's worth it for us to look each other in the eyes. And that's because 83% of everything is carried through the visual system. And this system has to be in place. Once it's in place, you cannot just see it. If we've been friends for 20 years, it wouldn't be a problem. We just call each other because we know. But when we establish first contact, in Star Trek or anything else, but if we establish the first contact, the next 2 or 3 meetings we have to do that face to face. Then we can go to a video conference. Then we can do screencasting. Then we can do Skype meetings. And at the end we can call each other. And on a good day we don't even need to call each other because I know what you would choose if I've known you for 20 years. And that's the way we build up, but we can't snap the first connection. We need to see each other. And it means everything to us. But the tricky thing here is that when we evolved in Central Africa, when we evolved here, we think we are in daylight. We think we are standing on the savannah because that's what the system is calibrated for. So when we look each other in the eye, we assume that we have perfect visual conditions. We assume that we have daylight, which has a color rendering index of 100. It's perfect color rendering. A light source like this has a color rendering of 80. So we take 20%, throw it away. So we're already narrowing the bandwidth. The worse the lighting is, the more we narrow the bandwidth. You're sitting in a little dark corner, it's hard It's harder to read your face than his face, so I'm losing bandwidth in our communication compared to our communication. And it seems to be so much worse that we are traveling the world and then we destroy it by having crappy lighting. It's amazing, isn't it? So it's some of the things that are so important, and that's what the book is about. It's the value of visual communication between people. And we know that because it takes us 7 seconds to make up our first impressions. Do you trust me? Do I trust you guys? If I want to buy a used car from you, I will drive into your driveway. I've never seen you before, and the moment I walk up to you, I make up my mind. Can I trust that guy? Would I buy a used car from that guy? Or does it feel wrong somehow? It's the scenery, there are scrap cars all over the place or whatever. So it's, we do that all the time, and that's why these first impressions are so very, very important. Now we know that eye contact releases oxytocin, and oxytocin is our connecting hormone, it's our falling in love hormone. So when we look people in the eye, we release oxytocin. It's a complex molecule that looks like this, and it's what connects families, it's what connects parents with their children, it's what makes people it is what makes people fall in love. And 3 seconds is enough. 3 seconds, when you look somebody in the eye, you release oxytocin. You can put it in the bloodstream and measure it. You look somebody in the eye, poof, 3 seconds. And when you learn visual communication, you know that if I'm looking at you less than 3 seconds, you feel neglected, overlooked. And if I look at you longer than 7 seconds, you feel I'm staring at you. That's why we move our eyes all the time. We cannot have eye contact for longer than 7 seconds. It becomes weird. Why is he staring at me? It's scary. And why is he neglecting me if we are less than 3 seconds? And it's the curve of oxytocin that controls that. So imagine that 3 seconds is enough, that when we look each other in the eye, and we do that, especially when we get a newborn baby, and the baby looks back, and that's the connection that lasts for a lifetime, because you stare that baby in the eye. You never get bored about looking, oh, you goody baby in the eyes all the time, and you just keep pumping oxytocin. And when you're in love with somebody, when you meet somebody, you can be sitting there an entire evening with a candle in front of us, just looking, you're wonderful. And that's because we get that massive kick of oxytocin. Now the challenge we have with our young people today is we can have them at the dinner table, we can have them in the couch, we can have them in the room, but they don't look at us. They talk to us, but they don't look at us. They don't look at each other, they look at their screens. So what you do now is you look at your newborn babies, you look at your lovers, and you stop looking at your phone, because it breaks the band between families, between friends, between children and adults. So it's a really big issue that we are working with psychologists all over the world. And we try to do lighting that sustains. You look at people, you interact with people, but you can't make people. It's like when we were reading a book when we were kids, and said, stop reading the book when we were eating. So we actually need to be together and look at each other for a biological reason. So these 3 circles, the visual, the biological, and the emotional, if you can do really, really good lighting, then you're in here in the middle where you create what we hope to call well-being. Because if you do that, if you dose the right oxytocin, you dose the right cortisol level by means of biological control, you create the emotional light so you feel it fits the purpose, you feel safe, you feel secure, and up here you have enough light to do a good visual task. You can read your papers, you look at each other, and it's not discomforting in any way. Then we made it. And it's not that easy, but it's fun to do. Most of us, everybody in the industry does that. Most of us does one of the other things, and we of course the only one who does everything. So that's actually what we are striving for. We're trying to create that well-being by being in the center of that. And that's all very fine, and we call that, the definition of human-centric lighting is that it's lighting devoted to enhancing human performance, comfort, health and well-being, all the stuff I've covered, and it's either individually or in combination. And that's the definition that was put forward by Peter Boyce in 2016. So you don't have to do it everywhere, but you have to think about it. What do I want to do here? Is this a place of feeling? Is this a place of biology? Is this a place of performance? And here, in this purpose, it's communication, and I want you to feel engaged somehow. It's very few of you that are sleeping now, and I'm very grateful for that, because you're actually with me here, and it's a great pleasure. So that's something about well-being. I feel good. We have a visual performance. We have comfort. So this is clearly human-centric lighting was done in here. So, well, the thing is energy efficiency, because everybody can do this, but it's not for free. And when we're looking at 15193, the energy standard for buildings, it comes like an iron ring that squeezes us in. And I'm trying to do what I do to you and to everybody who wants to listen to this. Please let us keep the space here, because if you're squeezing the energy use, we're cutting in here. We're losing some of the emotional factors. We're losing some of the biological, because we need to do that. That's legislation. So if we crush more of the lighting design community with higher energy demands, we just can't do it. When I started as an engineer 30 years ago, we had roughly 15 watt per square meters to do lighting with. Now we do it with 4.5. And we thought we have actually done our part. We've saved a lot of energy. But because the LED came up, and that was technology shift that makes us do the same lighting virtually at the same quality, but with much, much lower energy. But if we are going to be squeezed more, the line of the LED is flattening out. We cannot keep increasing efficiency. So if we are being beaten up to, let's say, 3 watt per square meters, it will start to scratch the edges here, and that's not good for anybody. So that's why we need to make people understand that lighting is not only about visual, it's just about the biological and the emotional factors. I'll ask you to carry that in your hearts with you when you leave here. An example about how we can do it, because there are, of course, good ways of doing that. We normally talked about installed effect power. We had 15 watt per square meters in the old days. That was more than enough to make brilliant lighting everywhere. That was very good. And we say in an office in the EU, we say we have 2,500 hours use of office time every year. And then when we do the math, well, we can then add it to kilowatt hour per square meter per year, and we will end up with around 37. So it's then 0.5 kilowatt hour per square meter per year. And that's with a lot of control system. And one of the challenges we are facing is that light's on all the time. We are not good at switching it off. So it's a heavy use. So with this one, we can make brilliant lighting design. So if we lock that in and keep the 15 watt per square meters, as we would like to do in the future, over here, then how can we save energy? Well, we can save energy by putting in intelligent controls, just like you share with us using your your systems. We use 4 different parameters. We have an intelligent system that helps us. We only turn the light on, it switches off itself, because if we have a system that turned the light on, that would be unnecessary until there has to be a human interaction to say, okay, I want more light now, so I have to do something. But as soon as the lighting condition is there's enough daylight, then it will be fine that it could switch off. It has a remote control, so you can program it. It has a daylight sensor inside, how much light is coming in through the windows, so you actually can monitor that, and you can supplement with the electric lighting. And then finally it detects, is there somebody in the room? Because if people leave, let's switch off the light. And in the Middle East, let's say in Saudi Arabia, in Abu Dhabi, Dubai area, you don't switch off the light. It's just on all the time, because they have oil and they have lots of energy. They don't care about it. So it's hard to come in with some of the arguments down there. But in the rest of the world, where we have limited energy resources, if we put in intelligent controls in a standard office, we're looking at around the need for light for 1,000 hours a year. So it's a massive decrease in energy, and that's why we are so happy that we got it into the new EU legislation to work with LENI, a lighting energy numerical indicator, where we talk about energy use instead of installed effect. It's not so interesting if we put in hundreds of watt. It's interesting how much we use it. So when you see these calculations here, where you have daylight coming in and you have an index of that, then that's where you see these calculations, that with a good lighting control system, you can actually save somewhere between 40 and 50% of your lighting bill, of the electricity bill for lighting. And that's normally what we sell in. So today we don't do any new lighting designs without having a pretty advanced control system that switches or dims the light when there's enough daylight in there. So it is actually possible, compared to the switches that we know when we turn the light on and off at the door, that it could be an intelligent system. So there's a vast saving potential in looking at your lighting in buildings, especially in countries where you don't even have a switch at the door. We have like a main switch in the basement, and you turn on the entire building and you never switch it off again. So if you are a few light nerds, there's at least one light nerd like myself down here, so it's good to see you. When we had fluorescent tubes, we couldn't just switch them on and off. They needed to be switched on for 15 minutes to get the gas vaporized pressure inside, to get the energy flowing and to make it condensate again. So you could not just switch fluorescent lamps on and off like that. So whenever you had a dimming system where people left the room, you had an after run time of 15 minutes before you switched off the light, so you always needed to have it on for 15 minutes. So that means in a school, in every break, the lights were on in the classroom. But with LEDs like this one, they don't care about being switched on and off. So that's already a big potential that you can switch it off as soon as people turn their back. Right now, I don't know if this screen is on, and it doesn't mean much to me, but when I turn around, I would love to see that it's on. And it's the same with lighting. It's the visual field. If we had a very sensitive system and I was alone in the room, it didn't mean if there was any light behind me. I wouldn't care until I turned around, then all that light could switch off. We're not really there yet, but that's some of the perspectives. You have heard everything I know, so that's not much, but you heard it for an hour. I appreciate everybody stayed and a few came in, and I would like to take 3 things that you just remember after today. That light is a carrier of visual communication between you, your children, your loved one, your colleagues, your negotiation partners. I've worked both with Scotland Yard and the Border Police doing interrogation rooms, because if you find some weird serial killer and put him in there, you want the best bandwidth when you're interrogating him. And these people, it's like athletes, elite sports people. They will do everything to get every information out of people. The same at border controls when you are going through the green, nothing to declare, or through the red. The police are looking there. They're looking for some clues. The lighting there is brilliant because they need that bandwidth. So in every way, remember that light is a carrier of communication. And then from now on, the rest of our life, use daylight, have overlying windows, have good glazing, have lots of daylight coming in, and a good control system that dims the light in here as soon as daylight comes in. It's better quality light, or at least just as good, and it's for free yet. So we'll see about that. And remember, if you put in a control system, your saving potentially, as a rule of thumb, is half. So whenever people are saying, should we install a system? Yes, of course you should. And it's very rare that we don't do it today, but there are still countries, there's still massive amount of Russia, Poland, Estonia, Lithuania, that way over there, it's on-off switches. So it's there big potential in the world. So I will take these 3 things for you to take home. Light is a carrier of communication, use daylight, and use control systems. Thank you very much for staying for an hour.